So here we're going to be talking about functions, parent functions, and representing functions. Lots of different stuff to talk about, but this stuff is not relatively difficult. So the first part we're going to talk about is function or not a function. Remember, something is a function, and this is points, graphs, whatever, if the x value doesn't repeat. If the x value doesn't repeat, that means something is a function. And we don't even look at the y value. We only look at the x value. So if the x value doesn't repeat, then it is a function. Now that's easy to tell from points or tables or maps. That's harder to tell from a graph. So if it's a graph, if it's a function, it passes the vertical line test, which means if you draw a vertical line, it will only touch the graph once. It will only touch the graph once. And what I mean by that is if you have, let's say you have two different graphs here, and this guy, let's see, this guy goes like this, and this guy goes like this. Okay? If I were to draw a vertical line here, any of these vertical lines, it's only ever going to hit in one spot. Once. But if I draw a vertical line here, it's going to hit 1, 2, 3. That would not be a function. Okay? So those are kind of the things we've talked about before, for sure. But let's look at it in actual questions. So right here, which of the following does not represent a function? So we know it's a function if the x values do not repeat. So we're only looking at the x values here. -3, -1, 1, and 3. None of those repeat, so that is a function, so I'm going to cross that off because I'm looking for one that's not a function. -4, -1, 0, and 5. None of those repeat, so that is also a function. -6, -4, -1, and 1. None of those repeat, so that is also a function. -2, -2, 0, and 1. Well, two -2s. That is not a function because they repeat. D is not a function there. Okay, that's the correct answer. On this next one, which of the following graphs does not represent y as a function? So it's not a function. And now I have a graph, so I have to do the vertical line test here. So if I were to draw vertical lines on this graph, it's only ever going to hit it in one spot. That is a function. Okay? So I'm looking for one that's not a function. Here, it's kind of hard to see. I'm showing you a graph. This is a quadratic graph that looks like this. If I were to draw lines here, it's only ever hitting it in one spot. So that's also a function. This is a graph that looks like this. And this one, I mean, if I draw lines over here, there's nothing. But if I draw lines here, look, it's hitting it in more than one spot. This one is not a function because it fails the vertical line test, VLT, vertical line test. And just to check over here, this one, a lot of kids will say this one's not a function because, oh, if I draw a line here, it's going to hit. It is pretty steep, but even if I draw one line, it's still only going to hit in one spot. So that one right there is not a function. The rest are. So now we have parent functions. Okay, this is really important, so make sure you're really paying attention. The linear parent function is y equals x. The quadratic parent function is y equals x squared. That is something you just have to memorize. Linear is y equals x. Quadratic is y equals x squared. Okay? And whenever you see parent function, you automatically need to go to one of those two things. Okay? And we're going to use our calculators and answer some of these questions. So the first one says, which of these are characteristics of the parent function of a quadratic? So automatically to the side, I need you to write y equals x squared. And it says the parent function of a quadratic has a vertex at 0, 0. Well, maybe you don't know. Well, that's fine. It's an equation we can put in the calculator, right? So let's go to, let me move my calculator so you can see it. There we go. We go to y equals, and we type in x squared, and we graph it. And it says it has a vertex at 0, 0. Is the vertex there at 0, 0? Yeah, looks like it. So that one is correct. The parent function does have a vertex at 0, 0. The parent function of a quadratic equation opens downward. So if I look at that graph, is this opening downward? No, it's opening upward. It's positive. So I do know that this one is incorrect. the parent function of a quadratic equation has the y-axis as its line of symmetry. Remember, line of symmetry is a vertical line that cuts it in half. So let's see. This is my y-axis right here. Is that the line of symmetry? Yeah, it is. It's cutting that graph in half. And just by looking at y equals x squared, you probably can't answer those questions. But if you graph it in the calculator and look at it, you can. So this is also correct. So I need 1 and 3. This is 1 and 2. 1 and 3, that looks good. 2 and 3, no. 1, 2, and 3, also no. G is correct. 1 and 3. Okay? This next one down here. Which graph below best represents the linear parent function? So if you ever see that linear parent function, y equals x, always. Y equals x. And maybe you don't know what the linear parent function looks like. So you go to your calculator, and you go to y equals, clear that out, and just y equals x. And I'm going to graph it so I can visually see what it looks like. And it looks like a diagonal line going through the middle. So if I look at my stuff, that one is negative, so no. Not a diagonal line, not a diagonal line. Yes, diagonal line going through the middle. Alright, so y equals x squared, put them into the calculator, and then see what is happening there. Okay? Oops, sorry, got that there. Let me move this down a little bit so I can do that. There we go. Okay. So here, representing functions. Let's move that back up a little bit. Good. Representing functions. You're going to have a couple of these. It's going to give you some points, and it's going to say which one can or which one cannot match it. So when you have this, if possible, you might need to plot points. You might need to go to y equals in your calculator and go to the graph or the table. You might need to do a bunch of different stuff, okay? But you just got to see which one works out, and you're going to be eliminating. So here, the function f of x has these 4 points in them. Very important. It can be represented in several ways. It could be a map, a table, a graph, an equation, all sorts of stuff. Which one is not a correct representation? So we're just going to go through one by one. So this says 1, 2. This says 1, 2. 2, 4, 2, 4, 3, 6, 3, 6, 4, 8, 4, 8. This one is a representation. So I'm going to cross it off because I'm looking for one that's not. Okay, this one says 1, 2. And if I go over 1 up 2, that's right there. So that doesn't look so good. 2, 4. If I go over 2 up 1, 2, 3, 4. 3, 6. And 4, 8. Are those points matching the ones that are on the graph? No, it's not. So this one looks pretty good. That looks like it's not a good representation. H says x is a natural number less than 5 and y is twice x. Okay? X is a natural number less than 5 and y is twice x. So are all these x values less than 5? 1, 2, 3, 4? Yeah, they're less than 5. And y is twice x. So twice. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. So that's a weirdly written question, but that is correct. And y equals 2x, which you could go to 2x in the calculator and go to the table, and yep, that's true. And the domain is 1, 2, 3, and 4. And remember, domain are the x values. So, and if I look at my domain, 1, 2, 3, and 4. So that's also true. Okay, so the correct answer is G. That graph does not match the ones that I have there. Okay? Now representing patterns. These are questions that kids miss a lot, but they're actually super easy, okay? The first thing I want you to do is I want you to make a table. You make a table, and then you put your answer choices into y equals and see which one matches. Okay? So here's what I mean by make a table. I have this pattern and all these equations and it looks super crazy hard, but it's not. I'm going to make a little xy table here. And 1, 2, 3, and 4, those are my x's. 1, 2, 3, and 4. And it may not say stage 1, stage 2, but this is the first object, so 1. That's the second object, so 2. And then I'm going to put how many boxes are there. So 1, 2, 3, 4, 5, 6, 7. So 1, 7. 2 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I have this table, and I need to figure out which one of these will match it. So I'm going to my calculator. Scroll it over here so you can see here. So I go to y equals, clear out my other stuff, and I type in 4n plus 3. Although you're not going to type in n, you're going to type in x. And I'm going to go to the table, second graph. And this says 1, 7, so that matches. 2, 12, nope, that says 2, 11, so automatically I know that this one right here is wrong. So let's try the next one. Go to y equals, type it in, 5x plus 2. Go to the table. That says 1, 7, 2, 12, that matches. 3, 17, that looks good. 4, 22, yep, this one matches. So G is correct. You could check H and J to see if they're correct, but they give you a different table and G would be right. So there you go. Function, not a function, parent functions, representing functions, and making patterns. All types of questions you're going to have on your EOC. If you have any questions, please do not hesitate to ask.